Welcome to this video. In this video, we will learn about measurement of length or the length measurement, methods of measuring length. Okay, but before that, if we summarize what we have done so far in this chapter, uh, are the thing what we have done in this chapter are physical quantity and its measurement we discussed. Then we learn about systems of measurement, and then I explain especially on radian, degree and degree, minute and second, conversion of these units. As a student of science or physics student, always remember this the radian which we discussed in our previous class about radian, that how to convert it into degree, then minute, then second. That will help you a lot in the entire physics. You'll find very frequently use of those things. Okay. And beside this, what I advise is always make the habit of writing in a diary to note down important relations, okay, values of certain constant and important formulae. Whether you are in a class or whether you are learning through such tutorial, here we try to explain, and you also learn everything in detail. But when you sit for revision later on, you will not get enough time to go through everything in detail. Okay, so the habit of making formula diary is a good habit which will help you a lot, but you must refer that diary daily. Okay, so just make a habit. This will help you a lot. Okay, so today here we shall learn about measurement of length and methods of measuring length. Okay, so let's go for this. Your measurement of length already I wrote here. So see, when we talk about length measurement and the methods of measuring length, basically we get two types of length measurement method or methods of measuring length. Okay, the first one is direct method, and the second is indirect method, direct and indirect method. So these two methods we will learn here. I will explain those two methods, and basically in this session I will focus mainly on one very important method called parallax method, which we will learn here. Okay, so let's start now. So when we talk about measurement of length, we know there are two types of length measurements, as I said. Number one, let me start here only. Methods of measuring length or length measurement. So here you will see two methods, and we will learn those things. The first is what you call direct method of length measurement. Second is indirect method method. Okay, these two method. So when we talk about this first direct method, these are those methods which we use in our daily life, or which we use or which are used by the common people, right? Indirect method we'll see a little later. So when we talk about this direct method, there are basically three types uh, are there, or three ways are there by which we measure the length directly. Directly means, uh, suppose if I want to find the length, like uh, 1 kilometer, or suppose 50 meter, 100 meter, that, or even 5 meter, 2 meter, right? 5 centimeter, 1 centimeter, or even some millimeter, right? So if this kind of length, if we want to measure, we can measure through certain instrument, okay, certain measuring device. Directly we can measure this thing what I said just now. So that comes under your direct method. So direct method, when we see, the first one is your done by meter scale. Okay, the measurement done by meter scale. Meter scale. So we know meter scale, it is something like this only, which has length of 1 meter. Yeah? So that is meter scale. So this can be used to measure for the range. This type of meter scale can measure 10 raised to minus 3 meter to 10 raised to power 2 meter. So what is this? This is very simple to understand. 10 raised to minus 3 meter means nothing but this 1 millimeter, and 10 raised to power 2 means 100 meter. 100 meter. So if you see this kind of a ruler scale, no, what you call ruler. So list count of this ruler, this measuring scale is 1 millimeter. Okay, so this, by this type of scale, or meter scale, or measuring device, ruler, we can measure the length of 1 millimeter to 100 meter to 100 meter. So this is one some tentative range. Okay, then if we talk about furthermore little smaller than this, then we use one very sophisticated device called by vernier caliper. Vernier caliper. This you will find in your practical. Okay, so there you will get chance to learn about this. So here also, if I get time, I will try to explain this vernier caliper, and one more is there called screw gauge. This we will, if I get time, I'll explain this thing. Okay, now this vernier caliper, this can measure the range of, it is for lengths, which can measure for lengths to an accuracy. Okay, accuracy of 10 to the power minus 4 meter. This is even 10 times smaller than 1 millimeter. No? 10 power minus 4 means 0.1 millimeter. This to 1 millimeter. So this is again a tentative range. Okay, so when you actually do practical in your practical classes or in your laboratory, there you will get this vernier caliper to measure this range of length. So this range is nothing but the width of something very thin object. Okay, then we talk about the third one is screw gauge. Okay, so this is done by screw gauge and spherometer. So this instrument can measure even smaller than what the vernier caliper does. Okay, so for this we consider the range for lengths less than 10 raised to minus 5 mm to 0.01 mm. So what is 0.01 mm? You can easily make out. So this range we can do by using this screw gauge. Okay, so this we will not go in detail now. We don't have this thing in detail, but these two, mainly vernier caliper and screw gauge spherometer, you will find in your practicals, right? Okay, so there you will learn in detail. So if I get time, I'll explain on this later on. Now let's go for your indirect method. So when we talk about indirect methods, there are so many indirect methods, but before that, let me tell you one thing. So these are the thing where these are the what call those what call lengths which we can measure directly by using this kind of instrument, right? This kind of instrument, meter scale, vernier caliper, or screw gauge, or spherometer. Now suppose if I talk about certain situation, such a case. For example, if we want to measure the distance of 5 kilometer or 10 kilometer, okay, you cannot do by this meter scale. No? So it's very huge for measuring using meter scale. Even we can think about like distance between the planets, distance between the stars, no, in space, in universe. So those measurement you cannot do by simply using meter scale or this direct method, right? So this kind of long or large distances, okay, so those large distances we cannot do directly by this kind of instrument. So there we need some other sort of devices, some other technique, some other method. So such type of measurement can be done by using our intelligence, our skills, or our sense, right? So for very large distances or extremely very small distances, if we talk, see, direct method is the medium size range, medium size distance. But there are certain distances which are very, very large and which are very, very small, extremely large. So those kind of distances, if we want to measure, there we need our skill, there we need our intelligence and our sense. Okay, so I'll quote one example. Suppose I have a long thread. And I want to measure its length, right? So without using any measuring device, so there I can use some skill, some sort of intelligence. Like I can take one cylinder. I can take one cylinder of a definite length, okay, and the cylinder should be uniform throughout. So its area of cross section should be uniform. It is not something like one part is thicker, other part is thinner. So it should be should be of uniform cross section. Now if I take that cylinder and that long thread, if I wind around it, okay, if I wind around it, and it should be no, wound properly. So after winding it thoroughly, and if I count the number of turns there, then I can easily find the length of that thread. How? First, I need to know the circumference, means radius of that cylinder. Okay, the radius cylinder. Suppose r, if I know, and use its circumference 2 pi r. So that becomes the area of cross section of that cylinder. And to that circumference, if I multiply the number of turns, I will get the exact length of that thread. Okay, so here what I did, I just used the skill, I used the intelligence. So this kind of thing we can consider in the other category, where we need extremely large distances to measure and extremely small distances. Okay, so there we need indirect, this is called indirect method. Okay, so in case of indirect method, we use those things what I told just now, like your skill, your intelligence, and your sense. So using those things, you can measure those extremely large and extremely small distances, and that comes under your indirect method, right? Okay, now, so this indirect method is fully based on your intelligence, your skill, and your sense, right? Now, let's see what are those. We have so many indirect methods, but as I said, only few we will go for. So let's start. Number one is called reflection method or echo-reflection method. If you see, you'll find in your book also echo-reflection method. Echo or reflection method. Okay, then this is nothing, simply the reflection of sound. A sound wave is used here to measure the distance. You don't need any measuring device like what we used in direct method. Here this is done by some sort of that intelligence and skill we need here. The second one is, this is also very sophisticated device, we call laser method. So here we use light ray, okay, monochromatic light ray. Monochromatic means having single single wavelength, light with a single wavelength, no? Single color light we can say. So that kind of light we can use, and that light is intensified, and then it is beamed to the direction whose distance we need to find out. Okay, this is laser technology, the laser method. And then we have, next one is radar, R-A-D-A-R, radar method. Radar, here I use laser beam. Laser is the abbreviated form, which means light amplification through stimulated emission of radiation. Okay, this is the full form of your laser. So this is amplified and stimulated, then it is radiated to a particular direction. So that is your laser. Radar is radio detection and ranging. Here we use radio waves are used here. Then we have sonar method. So sonar method, again this is sound wave only we use, sound wave. This is sound and navigation ranging we call. This is basically used in submarines, used by submarines, and in marine exploration we use this one. Okay, then beside this, then we have parallax method. Parallax method. Then number 6 is your for very small distances, extremely small distances, extremely small distances. Let me write here, like that of molecules of oleic acid. This you have in your textbook also, this one. So extremely small distances. So this has range of this atomic size, okay, range of atomic size. What call that? That is of the range 10 raised to power minus 10 meter. That is called angstrom, right? So this range we can do using this one, okay? So molecules of this oleic acid, it is in your book, that's why I wrote this one. Otherwise any molecule we can talk about. So this is extremely, number 6 is extremely small distance measurement, and above 1 to 5 is extremely large distances, okay? So this can be used to measure extremely large distances, and this only is for your small, what call that, small range, extremely small distance, okay? Even smaller than what we have learned here is screw gauge and this vernier caliper. Okay, so here mainly we will focus on this one. Today's topic is based on parallax method. This is very important here. So we will learn this thing in detail, right? Now before going to parallax method, let me tell you one thing here. For all these 4 method, okay, for this I'll just give you one brief principle how we apply this method, this 4 these 4 methods in this length measurement. So here we use this simple formula. Distance is equal to velocity into time divided by 2, or distance equal to c, speed of light, into t by 2. Okay, this is the, we can say, working formula in such cases, in all of these 4 cases. Here v is the velocity of sound, okay, and here c is the velocity of light. So wherever I use sound here, we will use this v into t by 2 formula, and wherever we use light wave, there we use c into t by 2. So this very simple thing. How you can ask how from where we got this 2? It's very simple. This all are based on reflection method. All these 4 are basically based on reflection method. What they do, they send sound wave or light wave from one station to the station where you want to measure its distance. So suppose this is source, and this is the what call your destination, whose distance you need to find out, right? So what we can do, we can simply suppose this is your source from where you are sending this sound wave or light wave, and this is the far distant object whose distance we want to find. So we send this light or sound wave here, and this wave, when it reflect on this surface, from there it reflect back, okay? After incident on this, after striking this surface, the wave returns back, reflect back, and we receive that wave back here. So what we found here, first the wave goes to that point and returns back. So in doing so, it covers 2 distance. Suppose distance is d here, 1d, and again second d. So d plus d, 2d. So distance becomes twice d. And time measurement, time how will you measure? Simply the time when you send that wave, and the time when you receive that signal back. No? So that difference will give you the time, right? And if I know the speed, if I use sound wave, we know speed of sound in vacuum, we know. the value we know. So that value we can apply here. Time we can easily measure out, like 1 second, 2 second, going and coming. No? So that time difference. And if I use light, then we know the speed of light as well. So by using velocity, velocity of sound and time, look here, and velocity of speed and time, we can find out the distance. This 2 is for this 2s. So distance, distance is d. One first d, again coming back another d. So going and coming, you get d plus d, 2d. So if I use s, going distance s, and that returning distance is s again. So s plus s, 2s. So because of that, we get this 2. So this formula we can use to find the distance here. Okay, now let's go to this one, that is our what you call parallax method. Okay, let's learn this one. What is this? Parallax method. Parallax method. Okay, now parallax method, here one must know about this, so that this method is applied to measure very large distances. As we know, this all 5 what we wrote above here, all those 5 are for extremely large distances. But this parallax method, this can measure within the range of celestial bodies, within the range of 100 light year, less than 100 light year. So that much distance can be measured by this parallax method. Okay, so this is used for extremely large distances, like distance between the planets, between the stars, etc. Okay, so as I told, this method can be applied to measure the distances of stellar object which are within the range or less than 100 light years. Okay, so this is a very, very important method. That's why it is very important for your examination as well. So this is all about your parallax, means introduction about parallax method. So to know this, to understand this method, we must know first we must know the meaning of this word parallax, right? Then only we can understand what this all about. So we can write here, this method is applied to measure the extremely large distances, like planets and stars, etc. Up to the range of less than 100 light year. Okay, so this we should know. So this is the, we can say, the importance of your parallax method. But now, before going in detail, let's try to understand the meaning of this word parallax. Now, what is the meaning of this word parallax? So parallax is a simple term. Let me define here. First, let me write the definition and then we'll go for the explanation. Parallax. So it is nothing, the change in the position of an object with respect to the background when the object is seen from two different positions is known as parallax. I'll explain this. Let's see the definition again. It will be defined as the change in the position of an object with respect to the background when the object is seen from two different positions is known as parallax. Now, I think this is very simple. You're observing one object, okay, from two different positions. Suppose this is the object here. Let me keep here. This is the object, and this object is observed from two different positions. Now, when we see this again, one more thing. Here I wrote with respect to the background. That means it must have some background here. It must have one background here. Background. That I will explain everything later on. Suppose this is the object and this is the background. This pen is the background, and you're looking from this 2 point, right? This 1 point, second point. So when we see this object from this point, this object from this position with respect to this background, and simultaneously from the second position, when you see this object with respect to that background, you will find there is a relative change in its position. This object will appear as if it is shifted by certain amount. Okay, so this particular phenomenon is called parallax. All right, so this can be done simple in our text, in your textbook. One example is given using a pen. Okay, so if you try to hold a pen near to your eyes and just take one background, suppose wall. If you take wall as a background, okay, and if you see that pen closing one eye at a time, okay, first you close your left eye and try to see that pen. That pen should be at your arm length. Okay, it's not like very far away from you. So just hold the pen at your arm length, and background is wall, and if you see that pen closing one eye, suppose left eye, if you close and see through your right eye, and again after that you close right eye and see from left eye, what you will find is you'll observe that slight change in the position of this pen there. You'll find slight change in its position. So that phenomenon is called parallax, right? So that is what I wrote here. The same thing. Now if I explain you, same thing here. If I explain you with, let me explain you actually with one diagram, one different example, because this will help you to understand exactly the parallax method instead of using this pen and the wall here. But the meaning will remain same here. If you see this pen and wall through your eyes, what you will find, what we observed before that is wall is a fixed reference, fixed screen, which do not change, okay, which does not change, but only the change in the position is observed on pen. Okay, so that is very important basis, that background should not change. Okay, and we should observe one object from two different positions. Now now let's take one example, right? Now example where let's take one daily day-to-day example. Now if I if suppose there is a tree, okay, if there is a tree, if suppose this is a tree, tree, and this is a highway. Suppose this is a highway. This is a highway. Now this is point A, position A, and here is position B. Okay, it is just like this A and B are nothing but your eyes, and this tree is nothing but we can compare with that pen. And there is one tower, long tower. Okay, there is a tower. This is a tower. Fine. This is a tower. This is a tower. This is tree. Now this two position means suppose you are going by your car, and you are at position A, and after some time you reach position B. You reach position B, right? So when you are in this position A, and when you look these two object, like this, this is how we see them. So what you find here is this tower. This is a tower. Okay, this is a tower, and this is a tree. Now what you find here, this tower for this position A, for you when you are in position A, this tower will be on your left side and this tree will be on your right side. Simple. Now as you are going to position B, and when you reach position B, and again when you see these two objects, okay, when you see these two objects, what you will observe here, these objects are there only, but since you have changed your you cover certain distance, you change your position. Now what you will observe here, this tree will be on your left and tower will go towards right. Isn't it? Simple concept. No? So what we found here? What we found here? We found that in moving from A to B, we find there is a change in the position of these two objects. See, earlier the tower was on your left and tree was on right. Now when you reach B, you found just opposite here. Okay, let's continue again. So this I think you understood now. So here what we find, there is a relative change in the position of these two objects. No? Or simply we can say, if I take this tree only and if I ignore tower, what I find, first I found this tree was on right side, and when I reach B, tree goes to my left side. So this is very clear from this another example, that here what is happening is the object is changing its position, okay, with respect to certain background. Here background is this tower. Now when it is observed from two different positions, so this phenomenon is called our parallax method. Okay, now one important thing here, this AB, this point of observation, these 2 points are called basis. This is called basis. It's very important, basis. As in case of our eyes, the distance between our eyes is called basis here, and this is the background, tower is the background, and this tree is that object. Okay, now this is what we call parallax. All right, now this concept, this phenomenon we can use in finding the length of distance of any object which is very far away from us, within the range of 100 light year or less than 100 light year. Okay, so that is very huge distance. So this can be applied there to get the distance. All right, now let's try to, after having now learn this one. Let's go for this method exactly. Let's see what we actually uh, uh, what call do in this method to get the distance which we are talking about. Fine. So this is that example where I try to explain you here. Yeah? So now let's move on to the method using this particular concept. Okay, so I'll go to next that exact thing. Suppose let me take here, let me take suppose this is one point. Let me mark this as P. P stands for a planet. It can be any star also. Let me write randomly a planet. And here is one star. S is one star. So what I did, this star I am comparing with the tower in my previous example, or that background as wall in your textbook. This P planet is the pen or the tree, right? Now what I will do, I'll mark one point here, point A, and somewhere here I'll mark point B. These are the two different places, place A and place B. And this A and B are nothing but the, see, we were talking about the parallax method. Okay, so that principle or the methodology what we use in this method, that is what we are learning now. So this A and B are two places. This is called observatory actually. This is one observatory, no, and this is second observatory. These two observatories. Okay, and from these two observatories we are observing this planet from both the observatories. All right, now let me tell you one thing. This particular situation can be realized in some other way. Like this is one observatory somewhere on the earth, okay, and this another observatory B, which is just diametrically opposite to this one. We know our earth is like a sphere. So if I take one point on one part, then it's just opposite, diametrically opposite on the other side, that is B. So you can think in that way also. Okay, but we don't need to take this what I said second one all the time. This can be done this way also. So A and B are two observatories on earth. So their distances are in few kilometers. Few kilometer distance between these two what call your observatories. Now let me write here this AB is the basis here. A and B are the basis here. This is basis, and this P is the object whose distance we want to know, we want to find. So distance, let me write capital D here. Okay, this distance we want to measure, and this is small b. This is small b, and if they form some, definitely they will form some angle here, right? So this angle is theta. Suppose this angle is theta. This is called parallax angle or parallactic angle, and we have this distant star here. Okay, so I don't need to join this. Why? Because this is for us, this is stationary, this is fixed background. Though we know star, nothing in universe, nothing is at rest, everything is moving. In fact, stars are moving more faster than how we do, our planet Earth does. So, but since the stars are very far away from us, that's why their distance compared, because of their distance, their speeds, their motion are taken very less in compared to the motion of the earth compared to us. Okay, otherwise stars, they move faster than how our earth does. But here we consider this is stationary. Why? Because its motion is very less compared to us because of its distance. Otherwise they are moving very fast. So that's why for us it seems like stationary. So that's why this is a fixed background, and taking this reference background, we observe this planet from observatory A and observatory B. So definitely the way how we learned in our previous example, you will find the relative change in the position. All right. Now see how this can be done so easily. Let me write here in a proper way. Let A and B be two observatories on the earth at a distance of few kilometers. Okay, so we can consider this thing. Fine. And this P be the planet whose distance is to be measured with respect to the fixed background S, that is star. Okay, simple. So this is the reference, we can say S is our that reference background, or whatever fixed background we can say here. Now as I told you, everything I explained here in this. So now let me write here. Then we can write AB as basis. We call it basis, okay? Basis, and whose length I considered small b. That this AP is equal to BP, almost equal we consider. BP, I consider D. Okay, what is this? This is the distance of planet from the earth, where we must know where B is very less than D. Remember, this is very important thing. Why? This A and B, this is like in distance of few kilometer. Okay, maybe 100 kilometer, 200 kilometer, 500 kilometer, not more than that. And D is the planet which is outside the earth, obviously. So it can be beyond our solar system as well. I'm not talking about our solar system only. And if you see the distance of that planet from earth, it will come in the range of thousands of kilometers, not thousand only, thousands of kilometers. So that's why thousands of kilometers is far bigger than this some few kilometers. Okay, so that's why B is very less than D. Now theta here, this theta, let theta be the parallax angle or parallactic angle. We can see there easily. Okay, so if I know all this thing, now I can make use of one small concept about the angle. See, we know this angle is very small. In our previous discussion, where we discuss about the measurement of radian, so that concept we can think here. Here also we'll use this angle in radian form only, not in degree or whatever. So always we'll try to convert, even if the angle is in degree, second or minute, you need to convert it into radian. Okay, fine. So if is a case, then see, let me explain here again. We know actually earth is not flat. See, I took A and B as a straight line here, but actually any two position on earth, if we talk strictly respect to geometry, this is like a curve. You'll find a curve here, small curve. It's a curve. So, and if I continue this one, you will get the huge, that circle here. You'll get one circle here, isn't it? I'll get one circle here with center P. If I take P as center, if I extend it to a circle, okay, P as a center. If you remember this form, this concept I'm using, taking P as center, and this is the circle what we discussed earlier. Already we did this thing. Now if I take this as radius, obviously this will be radius, isn't it? Now what about this two, A and B, the point what I took here, this is nothing but this is arc length L, and this is the angle formed by this arc at the center theta. Same thing here, theta is the angle formed by this basis two observatories, considering this P as center, planet as center. So if I use this one, what we get here? We get theta equal to L divided by R. This formula we know. This is mainly if you try to know this relation exactly. If you know the derivation of this relation, you make use of trigonometry, where we know tan theta equal to P by B, right? Perpendicular by this your base. And if theta is very, very small, if theta angle is very, very, very small, then we take theta equal to P by B. And this P and B, we can easily see here. If this theta is very, very small, we can take this AB as hypotenuse, sorry, perpendicular, and one of this radius as base, this as perpendicular and base. So that we can easily do by taking the help of trigonometry, how to derive this theta equal to L by R. But now we don't need this, because we know the definition of that general angle is nothing but the ratio of length of arc to the radius of the circle. This is how we define theta. So this concept we can use here. See, theta we have already here, theta is there. See, R, this R is nothing but D, and this L, length of the arc, is nothing but B here, okay, basis. So we can replace this formula L by R using D, B and theta. You can easily find out thereafter. Okay, so if where B is very, very less than D and theta is the parallel angle, where here I should write where theta is very small angle. This angle is very, very small. When you later on we'll see some examples of numerical, there you'll find this theta will be taken in terms of second or minute. So that's why this is very, very small angle. Very small angle. Then we can use this simple geometry. Then we can write, then theta is equal to L by R formula we can use, and this L we can take here B. No? So if I consider B as that length of the arc and radius as D, if B is equal to length of arc and D as radius, arc of circle, radius of circle, therefore I can use theta equal to B divided by D. And let me tell you again, this theta and B are known. Why? Because distance between two observatories, we can easily find out the distance between them. This is on earth only we can measure. And this theta, which we are talking here, theta, this can be measured by using devices, devices like your theodolite is there. There is one more device called sextant. So those type of device can be used to measure the value of theta. Okay, so this theta we can measure easily. No, the theta is not difficult to measure here. So now I can, what we know is theta and b both are known. We want to find d, so that's why our d will be b divided by theta. So this is what we found, the formula. So using this formula we can find out the distance of any that far object in the space or deep space. Okay, so this method is called parallax method. So here main thing is theta we must know. Theta should be measured. This theta is called parallactic angle or parallax angle that can be measured by using instrument. Special dedicated instruments are there. So using that we can measure this theta, and once we know the theta, that and b can be easily measured, so distance of that far object can be obtained by this formula. Okay, and remember here, as I told you earlier, this theta they may give you in second, they may give you in degree or in minute. So we must change those this theta in terms of radian. Okay, always remember here theta is in radian. You must convert it into radian. Done. So simply using simple concept, simple rule, we can find out the distance of far object. Okay, so this is what we call parallax method. Fine. Now in our next class we shall see some numerical on this parallax method and related topic. Okay, yeah, this much for today. Thank you.